the theory that connects your mind to the universe. Take a look at your hands. Go ahead. Feel the chair you're sitting on. Listen to the sound of my voice. These are all experiences, right? But what is the experience itself? We know there are neurons firing in your brain, a ridiculously complex dance of electricity and chemistry. But where, in all that biological machinery, does the feeling of redness or the sound of a song actually happen? Where does the sense of you come from? For a long time, the standard answer has been that consciousness is just something that pops out of all that complexity. Like a traffic jam emerges from a bunch of individual cars. It's a sort of ghost that mysteriously rises out of the machine. But what if that's not the whole story? What if the real answer isn't just in how the neurons are connected, but deep inside them? At a level of reality so bizarre, it connects your mind to the very fabric of the universe itself. So, is your awareness just the random chatter of atoms? A temporary illusion cooked up by a computer made of meat? Or is it something much, much deeper? Something woven into the basic rules of reality? There's a theory out there. It's controversial, but it just won't go away. That suggests your mind isn't just a product of everyday physics. It's a phenomenon of the quantum realm. It's an idea that doesn't just try to explain consciousness, but ties it directly to the geometry of spacetime. Section 1. The hard problem, a mystery science can't solve, yet. To get why we might need an idea this radical, we have to face what the philosopher David Chalmers called the hard problem of consciousness. The easy problems, and they're not easy at all, are things like figuring out how the brain processes information, focuses attention, or controls your body. We can stick you in an MRI and see which parts of your brain light up when you recognize your best friend or decide what to have for dinner. We can map the mechanics. But the hard problem is different. It's the question of why. All that physical stuff should feel like anything from the inside. Why does the firing of certain nerve fibers feel like pain? Why does a particular wavelength of light create the inner experience of the color blue? Classical neuroscience, which sees the brain as a super fancy biological computer, has no answer. It can describe all the parts of a TV set in perfect detail, but it can't explain the picture on the screen. It's this gap that has pushed some scientists to look past the world we know and into the weird, unbelievable world of quantum mechanics. Section 2. Enter the quantum realm, a different kind of reality. Okay, so the quantum world is famously strange. It's where a particle can be in multiple places at once. That's called superposition. It's where two particles can become entangled, so that messing with one instantly affects the other, even if they're on opposite sides of the galaxy. And it's a world where just looking at something seems to play a fundamental role, forcing all those fuzzy quantum possibilities to collapse into one single solid reality. For decades, everyone just assumed the brain was way too warm, wet, and noisy for any of this delicate quantum stuff to matter. Quantum states are incredibly fragile. The slightest disturbance from the environment can make them fall apart, a process called decoherence. Surely the messy, chaotic environment of a living brain cell would instantly destroy any quantum weirdness. The whole idea of a quantum mind was mostly written off as pseudoscience, but a few respected scientists just wouldn't let it go. They argued that nature might have already figured out how to use quantum tricks in the warm, wet world of biology. They point to things like photosynthesis in plants, or the way migrating birds use a quantum compass to navigate. If a bird can use quantum mechanics to find its way south, why couldn't our brains use it to create consciousness? Section 3. The theory, orchestrated objective reduction, OR. This brings us to the main event, a theory called orchestrated objective reduction, or OR for short. It was cooked up in the 1990s by two brilliant minds, Sir Roger Penrose, a Nobel Prize-winning physicist, and Dr. Stuart Hameroff, an anesthesiologist. Together, they built the most detailed and long-lasting quantum theory of consciousness. Their theory doesn't start with the neurons, but with what's inside them. Your brain cells are filled with a microscopic network of protein tubes called microtubules. Hameroff, from his work studying how anesthesia makes people lose consciousness, started to think these tubes were way more than just cell scaffolding. He proposed they were actually tiny quantum processors. According to OR, electrons inside the proteins of these microtubules can enter a state of quantum superposition, basically acting like quantum bits, or qubits. These quantum vibrations are kept safe and sound, or orchestrated, by the brain's biology, shielded from the noisy chaos of the cell, long enough to do some serious computing. That's the orchestrated part. But where does the feeling, the experience, come from? This is where Penrose's mind-bending physics comes in. He argued that when this quantum state collapses, it isn't random, and it isn't caused by someone looking at it. He proposed it's a real, physical process he calls objective reduction. Section 4. The cosmic connection, space-time and the soul. Here's where it gets really wild. Penrose suggests that every quantum superposition creates its own tiny blister in the fabric of space-time. When that superposition gets big enough, it becomes unstable and collapses under its own gravity. Imagine a tiny reality bubble that can only inflate so much before it pops on its own. And this is the most profound part of the theory. Penrose and Hameroff propose that every time one of these objective reductions happens, it creates a moment of conscious experience. Consciousness isn't something the brain calculates. Consciousness is the sequence of these collapses. It's a physical event, a flicker in reality itself. This idea connects our minds to the most fundamental level of the universe. It suggests the basic ingredients for experience, what some call proto-consciousness, are literally woven into the geometry of space-time. The brain, with its amazing microtubule network, has just evolved to capture and orchestrate these universal flickers into the steady, unified stream of awareness you call you. Your mind isn't just sitting in the universe, it's tapping into a process that is the universe. Section 5. The implications, rewriting reality, life, and free will. If a theory like OR is right, the fallout would be enormous. It could completely change how we see ourselves. For starters, it challenges the idea that the brain is just a machine. In classical physics, everything is cause and effect, which suggests your choices are basically predetermined. But if consciousness is tied to these quantum collapses, it might work in a way that's neither random nor predetermined. Penrose calls this non-computable, and it could finally open a scientific door for real, honest-to-goodness free will. The theory also points toward a philosophical idea called panpsychism, the notion that consciousness, or at least some primitive form of it, is a fundamental feature of reality. It suggests the universe isn't a dead place that accidentally woke up in a few of us. Instead, we might be resonating with a universe that is, in some very basic way, already awake. As Hameroff puts it, this could provide a scientific basis for things like interconnectedness, where our minds are fundamentally linked through quantum entanglement. Section 6. The skeptic's case. Is it all just a fantasy? Of course, an idea this big is going to have its critics, and OR has been under heavy fire for decades. The biggest scientific objection is still the decoherence problem. Physicists like MIT's Max Tegmark did the math and argued that the brain is just too warm and wet to maintain these quantum states for more than a tiny fraction of a second, nowhere near long enough to do anything useful. Proponents of OR have since claimed that Tegmark's calculations were flawed because he wasn't analyzing their specific model. But the criticism remains a major hurdle. Plus, critics point out that there's just not much direct proof. No one has actually seen quantum computing happen in a living brain's microtubules. Some philosophers, including David Chalmers himself, argue that even if the theory is correct, it doesn't truly solve the hard problem. It just moves the mystery. Why should a quantum collapse feel like anything? Others just see it as trying to solve one mystery, consciousness, with another, quantum gravity. For most neuroscientists, the safer bet is still that consciousness simply emerges from good old-fashioned brain cell activity. Section 7. The search for proof. Glimmers of evidence. Despite the pushback, the theory's defenders haven't given up, and lately, some interesting clues have started to surface. For example, we know that general anesthetics, which switch consciousness off, act on these very microtubules. To supporters, this is a huge piece of evidence. A 2024 study on rats found that when they were given a drug that made their microtubules more stable, it took significantly longer for anesthesia to knock them out. This suggests microtubules are a key target for losing consciousness. Other recent experiments have shown that microtubules can sustain certain quantum effects for much longer than skeptics first calculated, maybe even long enough to be relevant for brain processes. And new technologies, like creating tiny lab-grown brain organoids, are offering new ways to test these ideas without needing a human brain. Scientists can now poke and prod these mini-brains to see how they react to things known to affect consciousness. While none of this is a smoking gun, it shows that for the first time, the theory is becoming testable. So, what's your take? Is your consciousness an incredibly complex program running on a biological computer? Or are you connected to the cosmos through quantum music playing in the hidden architecture of your brain cells? This is one of the deepest questions we can possibly ask, and the science is far from settled. Let us know what you think down in the comments. And if you like getting your mind bent by the biggest questions in science, make sure you subscribe and hit that notification bell. Conclusion: the lingering question. We're at a fascinating fork in the road. One path leads to the brain as a machine, a beautiful, complicated system that we will, one day, fully understand using classical science. The other path leads to a much wilder vision, the brain as a quantum orchestra, and consciousness as the music it plays, a tune that harmonizes with the deep, underlying resonance of the universe itself. The Orchoir theory might end up being right, wrong, or somewhere in the middle, but its real value might be in how bold it is. It forces us to ask the biggest questions about who we are, and to wonder if the line separating our inner world from the outer universe is really there at all. It leaves you with one last lingering thought. When you look up at the stars, are you just an observer looking out at the universe? Or are you the universe, looking back at itself?